Hi everyone, Mario here with another Ruby2D tutorial. In today's session we're going to be looking at some collision detection, which is something that we've done previously before in our games, but we're just going to be focusing on collision detection and seeing how it works. Let's have a look and see what we're going to be building. So you can see here, this is the program that we're going to end up with. It's essentially just a bunch of boxes that are randomly going in different directions, and when they collide with each other they simply change the direction. So this is what we're going to build. It's not a full game, but it should be able to show off the particular technique that we're going to be doing. So here I have my Ruby2D program ready to go. I'm requiring the Ruby2D library, setting the background and the dimensions of the window, and then on each update we're just clearing the screen so we're not going to see anything, and show finally makes our program run. So let's execute and see what we have just to start off with. Okay, so you can see here not a lot happening, so the first thing we're going to do is draw the boxes on our screen. So the first thing I'm going to do is create an array to hold all of our boxes. So we're going to create a global variable here. We're going to need access to the boxes later on. Each box is going to need to know where all of the other boxes are to check whether or not it has collided with it. So a global variable will work fine for us here. So it's going to be an array. So we're going to create a new array. I'm going to, let's say, start with 40 different objects in the array. And each of those objects is going to be a box. So we haven't created this class yet. We will in a moment. Let's do that. Let's create our box class. And for each box that we create, we're going to need a few different things. So we're going to need a starting X and a Y position. We're going to also need to set the velocity of that box for both the X and the Y. So we're going to randomly pick all of those different things. So when we initialize our box, our X is going to be a number between 0 and the width of the window. So I'm going to say choose a random number up to window.width. And our Y will be the same thing, but up to the height. And we're going to need a velocity. So X velocity. So this is how many pixels it will move in the X direction. We want our boxes as well to move either left or right, so we need a negative or a positive number. So I'm going to say -5 to 5. We'll create a range. We'll use 2a to convert our range to an array. So we're going to get an array of -5, -4, all the way through to 0, and then 1, 2, 3, 4, 5. And we're going to say pick one of those at random. Our Y velocity will be the same. So -5 to 5, turn it into an array, and then pick one of those values. And then lastly, let's just create a method to draw our box. So I'm going to call that, let's say, draw. And to draw our box, I'm going to use a square. I'm going to create a new square. So the X position will be the X. The Y position will be the Y. We need to pick a size for our box. I think something like 15 will be fine. And then also a color. So one cool thing might be just to randomly pick a color for each of the boxes. So I'm going to do that in the initializer here as well. So I'm going to say color equals color.new, and you can give it the string random, and then that will just randomly generate a color for us. So our X position, our Y position, the size, and the color. Our color. Okay. And lastly, I just need to call this method inside of our loop because we're going to be clearing our screen every single time. So I'm going to clear our screen, and then I'm going to say for each of the boxes, call draw. Okay, let's run that and give it a go. Great. So you can see here our boxes are all in random positions and they're all random colors. The next step is to start getting them moving. So we already have the velocities here, the x and y velocities that we've randomly chosen. So we need to use those to change the box every time. So I'm going to create a new method here. Let's call it move. And what you want to do is you want to change the x and the y values based on this. So we're simply just going to add the x velocity each time. So let's say your x position is 100, your x velocity is 5. On the next spot you would be 105, then 110, and so on. If you're a negative number, you'd be going negative, so you'd go to 95 and then 90 and so on. So that's what we're going to do. So we're going to say our x is the current x plus the x velocity, and our y will be the same thing, so the current y plus the y velocity. Okay, let's see if our boxes are going to start moving. No, okay, so we've got to call the method that we just made move there. That should help. Okay, and that's a bit better. So you can see they're all moving at random different directions, random speeds. These two are really quite slow as well, you can see. But the one problem we have is that they're all just gone, they're all left the screen. So what I would like to do is and a really simple trick, so when they get to the end of the screen, they'll just appear on the other side. We've done this in the previous videos for the snake game, to let the snake appear across the other side, and it's going to be the same trick. So I'm simply just going to, instead of just letting the values get outside of the width, so the x can be below 0 and greater than the width of the window, what we're going to do is we're going to use the modulus to constrain it to that range. So if the width is, let's say, 1200 like we have here, when we use the modulus operator, it means that if our x position would be 1300, it would reset around to be 100, and the same thing with our y. So we're simply just taking the remainder when we divide it by the width and the height of the window. So to do that, I'm going to use the modulus operator here, which is the % sign, and then we're going to give it the value we're dividing by, which is the width here, and our y will be the same thing with our height. And so now when you run the program, what should happen is you should see them reappearing. So if we look at this green one here, you notice that it reappears on that same side. So they're all still there. So that's really good. So the next thing to do is the collision detection aspect. So we have our boxes. Now we're going to detect when they collide with each other. So when we look at our code here, the collision detection is actually going to happen not on the box class, but on this square instance here. So with these squares, we're going to be able to compare them against other squares using the built-in include method in Ruby2D. So on this square, we can call include, and we can give it an x and y coordinate, and it will tell us whether or not that x and y coordinate is contained within our square. So when the square and another square are going to overlap. And that's very useful, but it's not the whole picture, because we want to see if an entire square, if any part of that entire square contains another square. And so what we're going to do is we're going to use a few other methods that are on our square. So we actually have the methods x1, which represents the top left x position, x2 top right, and 3 and 4 and so on. So we have the x positions of all 4 of those corners and the y positions of all 4 of those corners, y1 through y4. So what we can do with those is we can use our include to see if any of the 4 corners of another square are included within our current square. And that's how we're going to do our detection. Here in our collision detection example, it's very simple because we have squares. You can imagine it actually becomes a lot more complicated when you come to more complicated shapes. So for example, something like a circle, it'd be much more difficult to do that. You would need a much more complicated formula to do it. Whereas for us, because it's 2 boxes, and the same could be for 2 rectangles, you can just check if any of the 4 corners of those are within the other shape. So let's get to it. So we're going to need access to this square here. So I'm going to put that into a instance variable. And on each loop of our game here, we're going to need to check for collisions. So I'm going to call check for collisions here. Okay, so let's make this method. Okay, so the first thing to be careful of here is the square actually only gets created when we call our draw. So there's going to be a time when, because we're doing this for each of the boxes, the first time we run, it's actually not going to work because the square is simply just not available yet. This will be not defined, so it'll come out to nil. So the first thing for our collision detection is we only want to run it if our square has already been defined. So we're going to put a condition around here. So we're going to say if square, and if our square is defined, we want to change the velocity if the collision, if we detect a collision. So we're going to say if square and collision detected, then when we collide, we'll simply just make it go in the opposite direction. So we're going to change the x velocity and the y velocity. We're going to reverse them. So we're going to say x velocity equals the opposite x velocity, and our y velocity equals the opposite y velocity. Okay, so let's implement our collision detected method. So to detect a collision, we're going to need to ask all of our boxes, hey, do you include the current box that we're in? So every single box needs to check every single other box to see if they have collided. So we're going to get the list of boxes here, and I'm going to take away the current box. So we don't want to check if our existing box has collided with itself because it'll always say yes. So we're going to take away this. So I'm going to say take away myself. So this here will simply, so boxes is an array. This code here will simply return a new array minus the current box that we have. And what we're going to say is we're going to say any of those other box, and on those other boxes we're going to say, hey, do you include my current square? Okay, and lastly we just need to implement this include method here. Okay, so in the include method, we've got access to our other square, and we have access to the current square. And now we can compare those two and see if any of those corners on the other square are inside of our current square. So we're going to use our current square. We're going to say, does this include the top left? So that will be other square x1, other square y1. We're going to say, does it include that, or does it include the top right, the bottom right, or the bottom left? So we're going to say or. So we've got 3 of those. And so this will be 2, 3, 4, y2, 3, 4. So again, this only applies for squares. It's quite simple for squares and rectangles. You're going to need to look up a different formula if you're doing a circle. If you're doing 3D shapes, it gets a lot more complicated as well. But this is a very basic, are any of the 4 points of this rectangle inside of our current rectangle? So here, top left, top right, bottom right, and bottom left. Let's see if this works. Okay, so I'm getting an error undefined method include, and it's happening on line 39. So it's because it's not include, it's contains. Okay, so running the program, you notice that a few of them are getting kind of stuck on each other and they're not kind of going anywhere. So let's have a look and see if we can figure out what's happening here. It's a bit jarring. Okay, so in our loop here, for each of the boxes, the first thing that we do is we check for collisions using this method. So if the collision is detected, then we reverse the x and the y velocity. The draw then will draw the box in its current position though, so we haven't yet modified the location of it using that x and y velocity, and then the move then does modify the position using the x and y velocity. So the issue is that we're not actually drawing it in that new position yet, so it's going to keep on going back and forth. So if we simply change the order of these operations so that we move it first and then draw it in that new position, hopefully they should kind of come apart. So let's try that. We're going to draw last and see if that fixes our behavior. Okay, so you can see there's a few colliding here, so that looks a lot better. None of them are getting stuck on each other, so that is something to look out for. It is actually quite easy to make it so that you're constantly having these collisions, so it's something to be careful of. One thing I might do just for a bit of fun is just to change the size of the boxes and just put a bit of variance. So we're going to do the same thing and pick a random size based on a range. So here, let's say 6 to 20. Cool. So it's a bit more interesting. There's a few different sizes there of boxes. So that's the basic collision detection here. Again, this technique will work for rectangles and squares. If you're doing something a bit more complicated, like a triangle or a circle, there are plenty of online formulas you can use for those kinds of things, but the easiest way is just to use squares, and then you can use this technique. So I hope that was enjoyable. All the code I'll post to GitHub just like normal. If you like the video, I'd really appreciate a like down the bottom there. And if you have any questions, feel free to ask, and I'll get to them as soon as I can. Thanks again. See you next time.